Welcome to the lecture series in computer science on principles of deep learning. In today's session, I am going to focus on sigmoid functions, and to take forward, we are going to discuss the various concepts under the sigmoid function. It is an activation function which we have already discussed in previous class. We are going to focus on how this will be implemented and what are the various applications of sigmoid and what are the challenges or the limitations of these activation functions for today's session. We discuss activation functions or special type of functions which will help in deep learning to analyze whether a neuron can be considered into the analysis or not, whether a neuron can be fired or not. So, in sigmoid functions, this is widely used in machine learning and deep learning as applications, and here this sigmoid function ranges the values between 0 and 1 in taking any ideal, in doing any of the predictions. If you see the mathematical formula over here, sigmoid function takes the formula 1 by 1 plus e power minus x, and if we see how this will be represented graphically, it is an S shaped function, and here if you see x1, x2 and so on, x1 are the input variables. We have assigned some initial values w0, w1, w2 and so on wn. If you have made the activation function, the summation, it results in sigma xi wi, and hence an activation function is being included, that is sigma of x, which gives and which in case says whether a neuron has to be activated or not. Moving on to the next concept, what is the need for a sigmoid function? Basically, we see different types of perceptrons, that is the multi-perceptron neuron, perceptron and multilinear perceptron. Here in all these cases, in the first case we consider the input output or the binary functions. So, when you give zeros and ones as an input, the output also is zeros and ones. If you take a perceptron, input value will be a real value, the output will be a binary value here, and this perceptron cannot handle linearly separable problems, non-separable problems. If you take the network of perceptron, the input is a real value, output is similarly the binary value, but this particular can handle the linearly non-separable problems. Now, moving on, why sigmoid functions are necessary in any of the machine learning or deep learning applications. Here we can consider input output are both real values, and the output of one sigmoid neuron is a real value between 0 and 1, and here this is smoother than the binary input. So, if you see, this is an S shaped curve, and the most it is commonly used in logistic functions. So, this is the main advantage of a sigmoid function. If you see the main difference between how graphically it will be represented, a perceptron is a very not smooth and it is not continuous function, while a sigmoid function is a smooth, continuous and differentiable function. Here we moving on to the actual case, why a sigmoid function is basically how it describes or how it takes the value between the threshold logic. We know in any real world, if we consider the threshold value of 0.5, we can just say that any value at the range of 0.49 or the value at the range of 0.51, how to be considered, whether we have to take that or we have to leave that. So, in all these cases, whether to like or dislike a movie, in case of this example, we can say that the values that is ranging from one particular threshold 0.5 either to the increasing order or to the decreasing order, we will say that the values will be considered in case of a sigmoid function. So, there comes the actual real usage of a sigmoid function. Now, see here from this figure, we understood that in case of a perceptron, the value will be 1 if sigma of weight associated with any input parameter is greater than 0, and it will be considered as 0 if the weightage multiplied with any input parameter is less than 0. in case of a sigmoid function, we just calculate using a mathematical formula, it is 1 by 1 plus e power sigma of the negation of or the negative value of sigma of w I x I. So, there comes the actual usage of the sigmoid. Now, moving on to the different properties a sigmoid function, the activating function can exhibit, we say that it is actually a real number which will be considered as an input, and the domain can be from minus infinity to infinity. It probably output values lies between 0 and 1, and this sigmoid value we will just consider the function at x is equal to 0 is 0.5. Moving on to the other properties, here this function is differentiable everywhere in the domain, and this function is continuous, and the derivative of any sigmoid function is bell shaped. Now, what are the different real world applications where this sigmoid activation function can be deployed? We understood that from the previous sessions that there are many different kinds of activation functions. The first and foremost we considered is the sigmoid function. Out of all these activation functions, sigmoid has its own limitations. Apart from that, this has been used in many different applications to choose a value whether to take it that yes or no values. Now, moving on to the first one of logistic regression, we understood that here in logistic regression you can directly take or predict any value to either true or false or yes or no. Here the sigmoid function applies the any particular algorithm in case of a logistic regression for the binary classification problems where there will be only yes or no values, and it helps us to map the predictions to probabilities. Now, moving on to the next one, the neural networks. These sigmoid functions are very well oftenly used as an activation function in neural networks. They help to determine whether any neuron should be activated or not. So, here the example usage of sigmoid comes. Moving on to the other applications, whether in case of a biology where the population growth can be rapidly increasing at the first level, you can just take this as a logistic growth, and here in case of population applications, you can just think of it whether the particular model, the population will be rapidly going or not. Moving on to the next application, the drug dosage response applications. These sigmoid functions model how the body will respond to the different levels of the drug dosage. At lower level, how the effects will be, whether it is minimal or maximum. At higher doses, how the levels will be, whether we can offer that or it will be harmful. The decisions of these will be based on the application of the sigmoid activation functions. Moving on to the market saturation, here you can just see that the model, the adoption of a product, whether it starts slow, increases rapidly, or eventually it may be slowed down for most of the people who have adopted the product. So, these type of effects can be well understood if you apply an activation function of sigmoid in your application. Now, moving on to the risk assessment, whether in case of a finance applications, you can just very well see that these sigmoid functions are very useful in risk modeling. That means, they helps us to determine the probability of whether a financial asset can be considered as a risk or not. Moving on to the other applications of smoothing, scaling and signal saturations. These are the well defined various real world applications where these sigmoid activation functions helps us to determine whether there are smooth data transmissions. It helps us to say in control systems whether the responses are desired in such a fashion that it can be considered for control of a temperature or any robotic operations or not. And moving on to the scaling, you can just think of the input values whether they are there in the desired range for any of the control applications. Moving on to the last one, in case of a telecommunication application, these sigmoid functions informs us or gives us the signals of radio waves or internet data whether to increase to any point of level or whether it has to be maximized or minimized based upon the capacity. Now, moving on to the other applications of decision making or behavior models, these sigmoid functions helps to understand or make decisions under uncertainty. For example, we wish to understand or take whether to choose between the way of taking into or considering the experience or the information of any of the real world applications, they helps us in decision making. And here in behavior models, you can just see whether a sigmoid function can behave like or take like a behavioral change, whether there is an addiction or there is a learning. These behavioral aspects can be slowly learned, or whether it will accelerate after or before stabilizing, we can very well understood using these activation functions. Now, moving on to the other applications, whether it is an edge detection in case of an image processing, they helps us to identify where the images, the pixel is intensified within any range, or whether there is a sharp contrast in the image detection or in the image where the curvature appears. Now, here in case of a personalized recommendation systems, we can see that these sigmoid functions helps us to predict whether the user preferences and behavior are taken place on a particular click or a particular recommendation has been done or not. Now, moving on to the challenges or what are the limitations that are faced by a sigmoid function while applied in any of the machine learning. Moving on to the challenges of a sigmoid function, now we will discuss what are the various limitations of the sigmoid function when we are applying in a real world. First one is the vanishing gradient problem. Here the issue is whether the sigmoid functions if applied to any larger values, whether they are positive or negative, this will eventually slow down the learning process, especially during the training segments in the deep neural networks. So, here we need to understand that the gradients will become very small when the inputs are large. Okay. Now, the other limitation is out of the range limitation, that is when the sigmoid function actually gives always the output values strictly to zeros and ones, which might be a limiting factor in certain situations of applications where you need a broader span of values, or the range of output values should be a broader span. So, those kinds of applications cannot be applied using the sigmoid functions, and when some negative outputs are required, this is also not possible, because sigmoid values output ranges from zeros to 1, which every positive output value will be a positive value only. Now, moving on to the other limitations of a sigmoid, it is of slow convergence. That means, this is relatively flat at both lower and higher ends of a domain. That means, the function's derivative is very small for large inputs, leading to the slower learning during the early stages of the training application, when you are training the input range or training the data set. So, not zero centered. That means, the sigmoid function always outputs the values between zeros and ones, which always says it is a positive value, and never its values will not oscillate to the other direction. It always oscillate to the one single direction. That means, there might be slow convergence in case of an optimization algorithms. Moving on to the other last type of problem, they can't be applied, or there might be difficulty while applying to a multi-class classification problems. This works well in case of a binary classification problem, but this will not be work well with the multi-class classifications. Only this will be better good if we apply some soft max also. That means, if we generalize the sigmoid with the soft max activation function, then this will be little bit possible in case of a multi-class classifications. So, these are the different limitations we come across when we apply the sigmoid activation functions in our real world applications. So, when our real world applications requires a situation where we need the negative span or we need a broader output. So, in those types of situations, this sigmoid cannot be applied, and we will move on to the other activation functions in line. Now, moving on. So, till now we have just discussed in deep learning situation, or when you are applying a deep learning network for any real world applications, we come across different activation functions, and in that we are just dealing with the sigmoid. Now, to know how deeply to apply the sigmoid application, we should have the basic knowledge of how these functions are available in Python libraries. Now, we will just go through a minimum of sample applications how these sigmoids can be implemented using Python libraries. Now, see this is a very simple example where we will as usual importing two libraries of Python to get implement this sigmoid application. Usually this activation functions can be applied to any normal input value that is taken as a set type, or it can be to any data set that is there in as a CSV file, or these can be applied to any image classification problems. So, these all the three types of problems we will just work it out in the Python libraries. Now, if you see the first two statements, it is just importing of different libraries in Python, the NumPy library and the matplotlib library, to just showcase how the sigmoid function will be there in the S shape. Now, moving on to, we are here calling the function here y is equal to sigmoid of x. Now, x is the value that we are going to take as an input parameter range, and this sigmoid function is already been given a definition of applying the formula, the mathematical function of the sigmoid. Now, before calling the sigmoid function, we are just sending the parameter values minus 10, 10 and the 100. So, this explains the start range, the end range, and how much ever values we wish to apply for the graph. Now, when we plot this graph, we are calling the plot function with the x value and y value. We are giving the title for the graph, whereby here the right hand side part signifies the sigmoid function title, and then in the x axis is labeled as x through this coding, the y axis is labeled as sigmoid of x, and here we are calling the grid value and showing the graph. So, this particular part reflects the actual graph that has been called with the input range, and this particular function or steps explains how to utilize or how to call a sigmoid function in using the Python libraries. So, here the output signifies that it is an S shaped graph where it converges smoothly from 0 to 1 range. Moving on to the second example, which gives us the derivative of a sigmoid function. Here we already understood that the derivative of a sigmoid function is given by the formula here. It is sigmoid of x into 1 minus sigmoid of x, and here to compute again the same values, we need to consider the x y values, and we are plotting the x and y values here by using the plot function, and we call the derivative function over here through the x parameter, and the value is being calculated to the y. Now, moving on to the actual phase of how the graph will be depicted, we have to set the x label as usual, it is set as x, and we are using the y label as the derivative, and we have given the title for the graph as derivative of a sigmoid function using the built-in functions in Python libraries x label, y label and the title functions. Now, here we call the plot with the grid function, and then we are asked to show the output. So, the derivative is an bell shaped output where it signifies the sigmoid function derivative value. Now, moving on, how this sigmoid is help in a logistic regression. We already discussed that the sigmoid is well relative to any logistic application or a population growth application, whether it says whether it converges to either 0 or 1. Now, here while applying this, we have taken the array values as 2, 3, 5, 7, 9. These are the input values that have been considered as the x, and y is an array of zeros and ones we have taken with the binary labels. Now, in this logistic regression, we have in Python the libraries like sklearn. This particular input library we are importing. Okay. The logistic regression library has been imported with the x and y values. We are calling logistic, there is a function called logistic regression in Python, where we call using these x and y values and we are fitting the model. Okay. Now, here in order to predict the probabilities, we call a method called model dot predict probability with these x values, and hence the values that have been predicted have been come into the variable called predictions. See, right hand side part is the part which I have executed the same code in the Google Colab, and the output is depicted as follows. Okay. The same code has been written, and here if you see, this is the predicted outputs. So, from the output we very well understood that the binary labels 0, 0, and here you are getting the values of ones, that is 0.7 which is equivalent to a 1 value, 0.94 which is probably equivalent to 1 value, and 0.99, and hence using the logistic regression we analyzed that the input labels what we have considered 0, 0, 1, 1, 1, what has been predicted, the predicted probabilities are one and the same, nearly it is actually exactly predicted the value, and hence by applying this logistic regression value, we have just modeled using the function how this sigmoid is being used in the logistic regression. Now, moving on, how this can be applied, the function where we will apply this function, the sigmoid function in logistic regression. Here one more example is being considered over here. Again, some of the input libraries have been imported, the NumPy library, matplotlib library, and here you have taken the logistic regression and make classification libraries for the data sets. Now, we consider the make classification is a function in Python library where some n samples have been taken, and how many features you wish, those randomized numbers as will be considered as clusters into the data set. So, these have been called, and you have taken the values of x and y. Now, we are using the logistic regression to fit the model. After fitting the model, we are using just scatter plot for featuring the class, how many values are there in class 0, class 1 and class 2. And here we called the linspace library, where this library will take the values of minimum and maximum of x values, and it will create the test data. And to predict the probability, we are applying a model dot predict underscore proper function, where x test data set have been taken as the input. Now, we are applying the function to just see that it is a decision boundary, and we are giving logistic regression with sigmoid as the function title. Okay. Now, moving on, how this sigmoid activation is used in the neural networks, how they can be applied. Here we are seeing that the sigmoid function, how it can be applied in various stages, from the simple function to the logistic regression and to the neural networks. And this example gives a clear cut example how this can be applied to a neural network. And if you see the output of this, here I have executed again the same code in the Google Colab. Here you see the variation, how the output, the target of 0 and 1 is achieved, and how the input of 1 and 2 have been depicted in the sigmoid activation. So, if you see the code of the sigmoid activation in neural networks, we already downloaded or imported the NumPy library, the matplotlib library, and we have applied the sigmoid function. We call the sigmoid function, neural network is being built, the class is being taken, and here the weights have been assigned. Randomly the weights have been assigned W1, W2, and the bias have been taken from the randomized number. Now, we applied a forward application, that is the feed forward thing, and then always the weight is being multiplied with the parameters. So, W1 is multiplied with x naught, W2 is multiplied with x1, and then we have added the bias value. Now, this z has been sent to the sigmoid function, okay, where this is an activation function. That means, in a neural network we understood that there might be several input parameters, weights will be there, and whichever the neuron has to be activated, only that neuron gets activated. Okay. And here we have applied the sigmoid function for this, and the data set that has been taken is given over in the general description or as an input value. Now, here how to create the neural network? We are using the built-in function called the neural network it just builds the neural networking, and here we are printing the input and output values and what is the target value we have. And here we have taken a mesh grid function, an array to apply these forward values, and we are reshaping the neural network output. And if you see the graph, the neural network decision boundaries have been applied for and two labels have been given for input 1 and input 2. And here the following graph gives us, in neural networks the sigmoid function is often used as an activation function, and the layers, it will say whether the neuron has to be taken into consideration or not. If you see the input 0 0 0 1 1 0 1 1, the output have been described with values 0.4, 0.1, 0.3, 0.1, and we got the target is been achieved or not, target 0, and the other 3 are the target 1. And here it introduces the non-linearity into the network, and thereby it learns the complex patterns and make the non-linear decisions. And the last example, or we see the example with respect to how to solve the vanishing gradient problem. So, how this problem can be solved? That means when the input values are very high, it approaches a 0 value. This, how to solve this is, you can just take the similar example we are taking, sigmoid function, we have implemented the sigmoid derivative function, and then we are calling the input values within the range of -10 to 10, and we are applying these functions. Okay. And the same thing, the output have been plotted using the matplotlib functions, whereby you will take values of x and y derivative. We are labeling the functions as the x axis to be labeled as x, y has to be labeled as sigmoid y. Here see, x has been labeled as x and y has been labeled as sigmoid of x, and now here you are just applying the problem, solving the problem and making the graph to be shown. See here at the gradient of -10, how the derivative function is bell shaped here, and at the gradient of 0, how the derivative function is being implemented at a 0 point. See here it is at the peak level over here, and at the value of 10, how the gradient values are being changing. So, this is being pictorially depicted using by considering the input value, how this derivative of sigmoid function helps to solve the problem. Now, we have seen through over the examples that sigmoid is very well suited for the binary classification problems. Now, what about the multi classifications? If there are several different classes, how this can be applied? This can be applied by taking a slight difference by applying the softmax function. So, this is an example program which gives us how this classification can be done using a multi-class. Multi-class problem can be solved using a softmax function. As usual, regularly we have taken the sigmoid definition and the softmax definition, and the binary classification with sigmoid gives the values like this. If you apply the binary classification for a multi-class problem using a softmax problem, so output have been defined like this. So, here you are taking a multi-class, the values have been taken, the array has been taken, and you have applied the softmax function, and we are asking to plot the subplots of this. And here when you consider a binary, the classes are zeros and ones. If you consider a multi-class, the classes are class 0, class 1 and class 2. So, if you see the layout by depicting the picture, here is an output when you execute the code in the Google Colab. So, under the binary classification problem, we are getting class 0 and class 1, but if you apply little of softmax function, whereby sigmoid can be applied to the multi-class classification. So, the classes have been differing in the output, class 0, class 1 and the class 2. And lastly, we come across a functionality or a code how this sigmoid can be applied in case of a image classification problem. So, for image classification, if you execute this particular code, we are applying here one more concept called the convolutional neural networks. So, these convolution neural networks, see here, this is the built-in function, and here you are calling the activation function called ReLU okay, and here we are calling the activation function called sigmoid. So, these will be well understood if we come across how a convolution neural network can be created, or how it can be applied for an image classification problems in neural networks. This we will discuss in little later in the next classes, but time being we will understood that how sigmoid can be applied in a image classification problem. So, here under image classification problem, these are the built in functions we need to import. One is the sequential, other one is the convolution network, max pooling, flatten and the dense. So, these are the libraries under the TensorFlow and Keras we are going to download, and here this is an image segmentation data MNIST data set, and here using those data set we are taking the training values and the testing values, and we are taking the shape function as 28 by 28 for the training data as well as the test data, and we are applying the classification, binary classification to that. We are converting that values, training values and testing values to that, and here now we are building the model. In building a model, we are just applying the convolution neural networks, and we are saying the activation function sigmoid to be applied over here. Okay. And these are the other parameters which will come across in later sessions, how the model has to be compiled with some optimizers. Okay. And while training here, we are fitting the model and we are deciding the epoch as 5. And now, if you execute this particular model, this is the output we are getting, and each of the epochs, if you see the accuracy is 0.9984, and hence here the test accuracy is 0.9984. So, here by applying the sigmoid function, how these images have been classified with an accuracy of this, we will just deeply discuss in next classes, but time being we will understand this is the actual code how we have to apply the sigmoid in the deep learning image classification applications. Okay. Now, to conclude the session, we understood that sigmoid is an activation function, and this is mainly helpful to say that whether a neuron has to be activated, when it has to be fired, etc. This function is a mathematical tool basically, and this we come across various different applications where it will be used in machine learning or in biology or in economics. Now, here the output range is always a positive value between 0 to 1. So, when you are mapping the probabilities or when you are taking the decisions, this always gives a smooth transition. And to move across the other things, this is helpful in logistical regression, neural networks, etc. And this function has its own limitations, and when you are applying for a complex problem, we can move into other activation functions like ReLU, TANH and the softmax, which we have little bit discussed. So, in subsequent sessions, I would like to concentrate on how these other activation functions like ReLU, TANH and softmax can be implemented to any other real world problems using the Python libraries.